Why not? Hi, everyone. I think I feel a bit overwhelmed because everything is on time and there's no technical issues. Nothing's crashed yet. So I'm feeling very overwhelmed. I don't even know what this is like. It's 12:05. We're super on time. What are we going to do with all this amazing extra time? I don't even know. I think we're just going to do some coding. Hope everyone is having a good day today. It's been a bit rainy today. It hasn't really stopped raining outside, which means that my internet is probably, well, just decimated by the rain. So currently coming to you live through a stream using Alvin's internet. And hopefully it all holds out today and none of that horrible buffering that you were experiencing yesterday, because that really takes away from the experience of the lecture. All right, so without further ado, let's get started. I hope everyone's been enjoying. I think Alvin said he actually went for brunch to a place with brunch. I mean, I'm so impressed. I still have not been able to go anywhere because of my cold, which has been very devastating. I just really want to go somewhere. I don't know where. Maybe to the pool. Oh, I can go to the pool. How exciting. I mean, I could just go outside. It's raining so hard. The pool's outside with all the rain. All right, let's get started. So yesterday we had this just a buffering adventure. That's what we had yesterday. And we had this lovely revisit of pointers. Everyone was super excited about pointers. Well, I don't think they were, but I mean, you'll get excited about pointers. Totally, you will get excited about pointers at some stage. Maybe it will come next year. But, you know, it will come. It will come. And hopefully, you know, with the week, the flex week, there are no classes next week, okay? No classes in week 6, which means that you guys actually have a chance to consolidate some of your knowledge, to actually think about things and to, you know, catch up a little bit as well. And I really hope that you then get to go out for a meal or just go out and see some friends, or just do, you know, have the time and the space to socialize a little bit as well. Now, remember that help sessions will continue running throughout week 6. So if you need help with your assignment, please log in. The details are on the website of how to log into the help session. And the timetable is also on the website. So please log in during those week 6 help session times and get help with your assignment as well. So there's no labs, there are no tutes, there are no lectures. Okay, we might be running a few fun streams that are sort of optional. You absolutely do not have to log in for them. Only if you want a bit of a break from your study. It's going to be not like content related or anything like that. So a week to, you know, breathe and kind of catch up a little bit, maybe just lie on the floor in fetal position, just thinking, thank goodness I've gotten to halfway. I'm halfway. It's almost Christmas break time, but hopefully that's not how you're feeling. Hopefully you're still feeling a little bit invigorated, a little bit enthusiastic, let's hope. And you can carry it for a further 4 weeks once the term goes again. Tomorrow, yesterday, look at me, I'm just having trouble with my days still, even though we're out of lockdown now. Yesterday, we looked at debugging some code as well. We looked at a piece of code that we fixed a lot of syntax errors. Before we even, you know, started fixing the syntax errors, people were pointing out the logic errors, which is absolutely amazing. So it was all happening. People are getting a really good sort of feel for doing the debugging stuff, which is really, really nice. And then we went through a few little strategies that you can use when you debug your code and when you look for errors off your code. Someone's asked a really nice questions as well in the chat. I can see, does assignment 2 get released straight after assignment 1 is due? So we are not that cruel. Only a little bit cruel, but not that cruel. So what happens is your assignment will be due, and then we're going to give you a little bit of time to breathe to the end of that week, and then we're going to release assignment 2. So you will get a break in assignments. So you will get a chance to just, you know, just calm down a little bit and relax a little bit. So we also looked at some special functions yesterday. We looked at getchar, we looked at putchar, and we also looked at a few other ones that are available to you, deciding if a character is a lowercase letter, uppercase letter, converting it to an upper or lowercase letter. So there's a few of them available to you. I've provided a few references and a few links that you can go to look at other functions that are available to you. You don't have to use these functions, but they do make your life a little bit easier if you know that this function exists. So they're a good idea because then you don't have to write the code. So it saves you a little bit of work. You just borrow this function and it can do whatever it is that you need it to do. So, you don't have to write the code. We're going to go through some more functions that might be useful today as well. So who knows, the world is our oyster. Yeah, Alvin, why are you hiding your fresh cut under a virtual hat? I should be hiding my hair under a virtual hat. I haven't had a haircut in like 4 months. Oh, I've gone the wrong way. Okay, today we are going to talk about strings, and I've called it a love story between arrays and characters because a string is an array of characters. So exciting. They're finally coming together halfway through the term, where they belong to make up a beautiful string. And we're going to talk more about the strings as we go for the first hour of today. And then we're going to talk about something else. We're going to talk about command line arguments. So you have inadvertently been using command line arguments for the last 5 weeks without even realizing it. And we're going to talk about what command line arguments are today. So just an exciting few hours in store for you. It is super worth it to be here over lunch and not out somewhere having a good time over lunch, because you're going to be having a better time here in the lecture. All right, so code today, and you can see it. I've checked and I've double checked. It is located in the week 5 location, so you can follow along. I've also moved up to using partially worked out examples in the code, so that we're only filling in sections of code, not the whole thing. All right, so let's talk about strings. Okay, this looks very heavy. So what I'm going to do, I'm actually going to switch to a drawing, and I'm going to draw a string for you because it's going to be super. Okay, let's do it. What is a string? A string is a whole bunch of characters joined together. So what have we done so far? So far, we have learned that we can have an array of numbers, which is really exciting. And we can load up that array by putting numbers into the array at certain indexes. And that's been an exciting thing to know because it allows us to store collections that are all of the same data types. So these are all ints. But what happens if we have a collection of all characters? So what happens if we have this array, and this array has some characters in it? So each one is going to be a char. What happens then? And again, it's still just an array, but it's an array of char. Well, at some stage, you are going to get a string, okay? If you join all those characters together, you can get a string. But there is one very special thing about a string. Right now, this array that I've drawn is not actually a string. It's just an array of characters, but it does not form a string. When you get a string, C does this really lovely thing for you that makes it a string. So if you have an array of characters that is in fact a string, what C does is it adds a very special character right at the very end of that array. And what that character is, it's a slash and a 0. Okay, and what that character means is we've come to the end of the string. So what it allows you to, oh, I did not mean to do that. That was very aggressive, I'm sorry. And whilst it has its own index, okay, this character here, this very special character that indicates that we've come to the end of a string, it doesn't get displayed when you're printing out a string. It doesn't get displayed at that stage. What it allows you to do is it allows you to loop through a string and know when you have come to the end of a string. So what's so special about a string is that it finishes in this lovely /0. So if we have this, so what's so array here, let's say it's called array. You guys have seen that this int array here up the top, it has 1, 2, 3, 4, 5, 6 elements. So that means I'm going to have a size of 6. And if I were initializing it, I would put 1, 2, 3, 4, 5, 6. Now, what happens when we initialize a string? So, I've written, no one's even pointed it out. I've written an int here. A string is not made up of ints, it's made up of chars. So we can have a char string array. And this array is going to be 1, 2, 3, 4, 5, 6 long, okay? Because you have to make space for this character here, okay? So you have to have an extra index that will accommodate that character. And the way that we actually initialize the string, there's 2 ways to do it, okay? This is the long way to do it. No, you will see it. You will see me doing it this way, and you will absolutely never do it this way again. But this is really what it means when you're doing it the short way. So what it's saying is I've got a character H in there. I've got a character E in there. And remember that I'm putting it in the single apostrophes because that's how we denote characters in C, because they're really ASCII values. And then I have an L, and I have another L, and I have an O. And then I also have this symbol here, which is my /0. And that's me initializing this array, okay? Now, this seems like a really hideous way to do it. You know, what happens if you have, hello, that's great. That's only got 5 letters. So I'm not going to insane. But what happens if I have, supercalifragilistic, blah, 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 and then this word is like just hugely long? There is a nicer way to initialize a string, okay? And the way we can do that is we can simply put it in double inverted commas, and there is a nicer way. So the double inverted commas is what tells C that it is in fact a string, okay? Which means that what C will do is it will create this type of array here that adds in this /0 by itself. So you don't need to even add it as long as you put it in the double inverted commas. So let's go back to our slides. Okay. It doesn't like it when I move things over. It just decides to come out of it. So again, it is a special array of characters that finishes with a /0. Okay, people are saying they're getting a weird echo. Okay, is that my microphone? Okay, people are saying they're getting a weird echo. Well, no, I should be talking into the Zoom. There's nothing else to talk into. It's not my overexcitement, I hope, that's echoing around the room. Only once in a while, okay. Oh. There it is again. Okay, Alvin is looking into it. Thank you, Alvin. Okay, so this symbol is called a null terminating character. Alvin is looking into it. Because obviously it's got a 0 and a slash. So that, okay, so this symbol it's called a null terminating character. So it's a \. I've gone the wrong way. Whoever said, yes, I have gone the wrong way. I was even looking at my keyboard to go the right way. I'm sorry. It's like the new line character, \. I can't believe it. Looked at my keyboard and went the wrong way anyway. It should be a \. If you haven't noticed, I have a big problem on left and right. Greater than, less looked than. Looked at my keyboard and now \/ anyway. It should be a \. Someone is saying my echo is worse. If you haven't noticed, I have a big problem on left and right. Sorry, greater than, less than. Looked at my keyboard and now \/ anyway. It should be a \. Someone is saying more nasal from every angle. I can't believe it. Looked at my keyboard and it should be. Someone is saying more nasal from every angle. Is it echoing every word now? Guys, I'm having a party. No, I'm not. I mean, just as we thought, there would be no technical problems. It's now all the time. Okay, what about now? Okay, is it better now? How are we feeling? Is it echoing? Is it just all nasal all around you? Just feeling my nasal voice? Is it echoing? By the cold. Is it just all nasal all around you? Just feeling my nasal voice? Is it echoing? By the cold. Is it just all nasal all around you? Just feeling my nasal voice? Is it echoing? By the cold. Is it just all nasal? Or am I okay? God. God. I don't want to try and speak. I don't want to echo further. I don't want to try and speak. I don't want to echo further. I don't want to try and speak. I don't want to echo further. You know what? Let me switch off my just in case one sasha wasn't enough and two sachets were not enough. You now have many. In case one sasha wasn't enough and two sachets were not enough. You now have many. In case one sasha wasn't enough. You now have many. In case one sasha wasn't enough. You now have many. In case one sasha wasn't enough. You now have many. In case one sasha wasn't enough. You now have many. In case one sasha wasn't enough. You now have many. In case one sasha wasn't enough. You now have many. In case one sasha wasn't enough. You now have many. In case one sasha wasn't enough. You now have many. In case one sasha.
I think. Can you guys hear me? I think you guys should be able to hear me. And I'm not echoing, right? Okay, let me try muting my... Okay, let me try muting my... Okay, let me try muting my...
Mute.
Okay.
How is the echo now?
Muting my...
Mute.
Okay.
How is the echo now?
Muting my...
Mute.
Okay.
Echo has stopped, someone says. Oh my gosh, we could be onto a winner. Only 2 minutes.
Okay.
Echo has stopped, someone says. Oh my gosh, we could be onto a winner. Nope, only 2 minutes. Okay. Echo has stopped, someone says. Oh my gosh, we could be onto a winner. Nope, only 2 minutes. Okay. Echo has stopped, someone says.
Oh. Okay, so now you've got me. I don't want to start lecturing. No. Let's try again. Audio output capture. Let's try again. Audio output capture. Let's try. Flasher, do you want to try and speak maybe? Sure.
I can try and speak.
Flasher,
hopefully I'm not echoing.
Speak maybe? Sure.
I can try and speak. Alvin, hopefully I'm not. Are you watching like the stream but also have me going through the Zoom. Alvin, you're being demoted. Is that fixed? Why can't we just have these lectures on Zoom? I have asked this same question. Okay, we're back. I think there's no echo now. Yeah. I mean, Alvin just felt that it was essential that we absolutely have a technical issue today. I don't know if you can see him, but he's just losing the plot over there now. So let's oh my gosh, Sander, no. Okay, we are CSE, but let's stop making our own platforms. There are too many platforms that CSE makes. Okay, here we go. We are back to strings. So exciting. Blackboard is terrible. Blackboard is worse. So the problem is the amount of people that we might have concurrently logging in, which is why these lectures are on YouTube. And so obviously my bad internet has not helped. Yesterday I called and yelled at well, I didn't yell. I was very polite because that's what I am, polite. At the internet service provider, but I'm also switching service providers that can guarantee me upload speeds. So hopefully when you come back in week 7, you won't even know what's going on. There's going to be not a technical issue in sight. So let's do this now. Let's go back to strings. Okay, so let's do it. I need to have a recording of Alvin and the Chipmunks when they do the Alvin, and then I'm just going to play it every time. Okay, so let's talk about it. So one very special thing about strings in C, and that it is an array of characters that finishes with a null terminating character, so a backslash and a 0, okay? So it's a very special character, and this symbol spelled correctly, if you would, with a Y, is called a null terminating character. It is always, always, always located at the end of an array, and the array has to be able to accommodate that character. And I'm going to do some weird things today in code to show you that what happens when I shove it in the middle of my array and what that does as well. So basically, just play around with things. As I usually say, it's great to break things because it really teaches you a lot about how things actually work. So there we go. So it's not displayed as part of the string, and it's basically a placeholder that indicates that this array of characters is a string, okay? So if you have that null terminating character, that means that that array of characters is in fact a string. So it's very useful to know when our string has come to an end, because that means that we can loop through an array of characters until we get to the end of string, and we can do something with it as well. So there's a lot of very neat things you can do by knowing when that array of when that array of characters, which is a string, has come to an end. Okay, so I've just drawn this for you. So let's say we have a character that's a character type array that's called word, and I've said that it's an array by using the square brackets type. This means that every single element is a char, and what I have is I will place the letters into my elements of the array, and then at the end of the array I have this beautiful null terminating character that is telling me that it is a string. So as before, the longhand way of writing it is to do each character separately at exactly how you do it with numbers, but then you also have to remember to include the null terminating character. However, you can do it the shorthand way, and obviously this is the more convenient way to do it as well, is if you put it in double apostrophes, okay? And then you just say the word, whatever the string is. So as soon as it's in double apostrophes, that means that it's a string. And what C will do is it will actually place the characters into the array and make space for this null terminating character. Okay, so how do we read a string? Okay, oh no, has it begun again? How can this be? Alvin, Alvin! Did you unmute something, Alvin? No? It can't be. Okay, seems fine. Okay. Oh, good. Now the dogs are barking, so that's good. You guys have the full array of what can happen today. I use the word array, just saying. Okay, so there is also a very useful function, okay, that we can use that is quite handy for reading strings, okay? So we can use, we can read strings by reading a character at a time, which is, you know, can be very painful. And obviously doing it a character at a time for basically a very, very long string would be quite painful because it would involve you reading many, many characters, the loop going through it many, many times. Also, it presents an opportunity for making many, many mistakes because once we have the loop, then we can do, you know, the more code you have, the more opportunity there is to make mistakes, obviously. I mean, not necessarily true, but the more stuff you write, the more opportunity there is to make a mistake when you're writing it without even meaning to. So there is a useful function that is there and available to you that is, you know, you just borrow. Well, you don't even need to borrow it. It's there in your standard input output. And that function is fgets, okay? So this function fgets is this lovely function that takes a whole line of input off your terminal, okay? So it takes a whole string and places it into an array. Now, fgets is a function that has 3 inputs into it, okay? And I've tried to break them down here. The first input into this function is the array that you will store the string into. So the array that you're planning to use to actually store whatever you're taking from terminal into. The second one is you're giving the length, so the number of characters that you will be reading in, okay? And this doesn't have to be the precise number. It could just be the maximum length of that array. So you are saying, how big is this array, okay? Which allows fgets to actually process what's going on and to make an array, you know, to make the space for it. So it knows where to insert that null terminating character as well. And then you've got this lovely thing called stream. So you don't have to worry about this. In 1511, there's only one stream that we use. That word is always going to be STDIN, which means standard input, okay? Usually out in the world, you might have 2 options. You might be reading from a file or you might be reading from the terminal input. Here in 1511, we're not going to be reading from files, so you don't have to worry about that. We're going to be reading from standard input. So you will use the word STDIN, okay? So let me demonstrate to you how this actually works, okay? Because I think it will really make it much easier for you to be able to see once we see a little bit of code about it. Okay, so this function here demonstrates the use of that function fgets, okay? So I've hash defined a maximum length for my array of 15 because as you remember, we like to give a size for which we want our array to be created because this allows C to know how much memory to allocate when it compiles, and that allows us to have the space available to us for that array. Okay, then I'm going to do, so what I've done is I've declared an array where I will place the string and I've called that array array. I've then printed out, type in a string to echo. So I'm going to take a string in on my terminal and then I want to read in a string until, so there's 2 ways to do it. Okay, let me do one string and then I'll do many strings. So I'm gonna zero this out, comment this out so you can see what happens just to use one one string. So if I use the function fgets, okay, it's going to have three things in it. Are we able to zoom in on the code? Let me have a look. Is it very small? Let me increase the size. How is this for code? Is that better? Okay. All right. So we have this lovely fgets now, and now we want three things to go into fgets. Okay. The first thing is the name of the array that we're going to be reading that line into. Okay. And the name of the array that I've got here is, I have this lovely array that I've called array, just to, you know, make it easier, I guess. So we are going to say array here because I'm reading into it. Now notice that I don't need to write the square brackets here, which is, I think, a question that someone asked. And the reason for that is because on my next item is going to be the size of the array, okay? So the size of the array, I'm going to say, is going to be max length, which is my hash define. And it's what, so I want an array of size 15. And then the next one, you're really always going to use this keyword here, stdin. It means standard input, and that means read in from terminal, okay? So what this line here does is it reads the line into this array. Now, if I want to print out what I've read in, just to show you that it's actually read the line in,
I'm not sure I understand.
Oh, good. My Siri's now going off. Fantastic. Now, I don't know, we're about to learn a new a new format specifier, and it's a %s, and that means string, okay? So I'm going to say the echo of the typed word in string is, and then whatever my % specify is, and then I'm going to do a new line. And then my, so Catherine's just says, so fgets is like a scanf for strings. Yeah. So we did the get char. Fgets is like your get char. Get char's for a character. Fgets is for lines of out of the terminal. Okay. And then my lovely is array. So let's try and run it and see if it's all going to come together. I think my terminal, how's my terminal? Is it a bit small as well? Let me increase the size of my terminal as well. Okay, how's that? Hopefully that's a bit better. Okay, so someone said they still don't get the standard input on line 18. stdin is telling me, no, not telling me, I don't need to tell myself anything, is me telling C where to read the input from, okay? So it's basically me saying to C, I would like to read from terminal, okay? So let's have a look. So let's compile it. And it's compiled, so now let's run it. Okay, I'm gonna do, okay, so what's happened here? So if you look at this here, I said type in a string to echo, and I've said technical issues are fun, and what it has echoed back at me is technical ISSU. So what's happened there? What do you reckon has happened there? Why has it broken off what I've typed in and didn't echo it properly? What do we reckon? Yeah, well done. Well done. So I've set my maximum length here as 15, which is going to make a maximum array size of 15. So I've run out of space. I've gone to my maximum length and then I've stopped. So I've went over that length of the array, and that's why it hasn't done the whole thing. If I change this and I make it 100, then it will absolutely be able to echo back anything, well, up to 100 things to me. Now, so now it's echoing back the whole thing at me. And if you notice, if the input is less, it doesn't matter. So you will fill up in that array that you're reading into, you will fill it up whilst there is stuff to fill up, and then you will stop, okay? But you will only be able to read up to that maximum length. So if you go over it, there's nowhere else for it to go because the memory for it has been created. And in my case now, the memory is of 100 characters. So that's the size of the array, and I can't really go over it. So if I've run out of space, I've not done a very good program because there's clearly not enough space to house what I want to house. Okay, and if you've noticed, it lets me echo things once and then it obviously exits out of the program because I don't have any sort of loop or anything happening. So what it does is it just asks me for one line of input, and then that's it. I print it back out and then I'm out. So what happens if I want to keep taking input in a line at a time, and then I want to just, keep going until a Control D is pressed, which is something that you have learned about in the last week, and it's so exciting. So there is a way to, of course, do it. And if you remember your get char, the get char reads until an end of file, okay, an EOF keyword, and that means we've come to an end. Control D has been pressed. fgets command reads until the keyword null. Okay, so null is the keyword that you want with fgets. And that is the keyword that says we've hit a Control D, so stop looping now. So I know it's two different keywords. They really mean very similar things. It means that there's nothing else there. But you do have to remember that for get char, it's an EOF, and for the lovely, fgets, it is going to be null. So if I want to keep reading, I want to keep taking input until a Control D is pressed, then I will call my fgets command. And again, it's going to have three inputs into it: the name of the array, the maximum length of this array that I'm creating, and where my input is coming from. And in your case, in 1511, that input is always going to come in from standard input, so always from stdin, so you don't have to worry so much about it. And if I want to keep reading until that Control D is pressed, then I'm going to keep reading until it's equal to null. So whilst it's not equal to null, I'm going to do, to print out my string, and then I'm going to say type in another string to echo, and I'm going to get that new string and go again and go again and go again. So let's see how that works in our piece of code. All right, and it's echoed back at me. It said the echo, and then it's taking the next one. How exciting. And the next one. What should we say as again? Oh, and the strings come back out at me again. And it will keep going until I press Control D. And you can see that when I press Control D, it has exited the building. Okay, it's come out and it's ready to, it's ready to not do this again because my while loop has finished. So what it does is it allows me to read things in and in and in and in and in and in until a Control D has been pressed. I know it's so harsh, but it's not really. It's not really true. He's not demoted. He knows it. All right, so we've got this lovely function that now allows us to also read whole lines. And the best part about it is you don't really have to write the code for it. You just use this function that is already available to you. So it really saves you a little bit of time. Oh, no, I don't want to do bullying. No, Alvin is really lovely. He's a really lovely person and a wonderful tutor. Okay, so let's have a look. So we've done our FGETs and we've talked about this lovely thing here. Okay, so just like we had our put char, okay, just like we had this get char, put char business, FGETs also has a cousin, a brother, a sister, a sibling. I don't know what we call it. So basically it has the opposite function. So FGETs is like your scanf. So it's taking input from the terminal. And then we've got our fputs is what puts it back out onto terminal. Again, you can use printf, okay? The choices are yours. You have all of these choices in what you feel is the most obvious way to do programming. And if you ever, go out and you program in the workplace, people have very specific sort of ways that they kind of program. It's kind of like slang and how we use language as well. We all have our very specific ways and specific quirks in the ways that we write code. And as long as we're following the style of code, it just depends how you prefer to code. But this gives you another function that is available to you, and it's called fputs. So it does exactly the same thing as this printf. I put out the whole array that, I stored some stuff in from the fgets. And then you can see this other keyword here, std out. And what's that saying is I am putting it out onto my standard output or onto terminal. And again, that exists there because there are multiple options. You're not always just working with terminal. In fact, you are often also working with files. And we don't work with files in 1511 anymore. But this gives you the option to say where you want to put this line out to. Do you want to put it out to a file or to your standard output, which is your terminal? And in this case, you're putting it out to terminal. And again, it's a keyword std out. It never changes. All it means is put this line out to terminal. So print it out onto terminal. And again, you'll notice that this fputs, it's not a formatted. So printf is a formatted way to print stuff out. Okay. But there's a heavier load to it because you need to have, you need to have your format specifies, you need to know what types you're doing and so on, and they need to match. Fputs is really just for these arrays. So the string that you have taken in, and that's what you're putting out there onto the terminal. So fputs is the same as line 15, exactly. So in this case, Theo, fputs is going to be exactly the same as line 15. So you can either have line 15 or you can have line 18. And as you can see, printf allows us to print sort of anything without having a variable or without giving it any input into it. But fputs will only print out whatever is stored inside that array. So if you want to write anything beforehand or afterhand, you'd still be using printf to, actually give any prompting. So there we go. So that's another exciting. And guess what? Yesterday we did lots and lots of character functions, which was really fun. There is also a whole bunch of string functions that are available to you. And right now you're probably thinking, oh my gosh, enough with all of these functions that I have to remember, enough with this already. But honestly, if you use these functions that are already available to you, they make your job so much easier. They really, you're able to kind of with one keyword or with one key function using something that's already made for you, they allow you to, do something that otherwise you'd have to write your own code for. So string libraries are located inside the string.h standard library. So that's quite nice. That seems to make sense. And if you remember, the characters were in C type, the strings are in string.h. And there is a whole bunch of them available to you. I've included a reference for you. If you want to go to that link, it has actually a whole bunch of string functions that are available to you to use. You're not going to use all of them really, but over the course of your programming, you might, go back and it will allow you to really see, okay, I want to do something with a string. First, I'll check the standard libraries to see if there is a function already for this before, I start writing my stuff myself. So some of the useful ones that you probably will be using, okay, you're going to have this string length one, strlen, and this one gives us the length of the string, and that excludes the null terminating character, okay? Then you have a string copy, which copies the contents of one string to another, which you'll see is going to be quite useful. There's a string cat, which concatenates two strings together, so it attaches one string to the end of another string and makes them one big string. There's a string compare. Now, the string compare compares two strings. So what that means is it will return a 0 if the strings are exactly the same, and it will, return something else if they're not the same. And there's two options that it can return, but it's not really important what they are, but 0 if the strings are exactly the same. So if you think about it, if you were doing a string compare, you'd have to compare it character by character if you were doing it manually. But this kind of allows you to just say straight away, if you just need to say, is this string the same as this string? You can do it by using this strcmp. And then we have this lovely, Catherine, what a fantastic question. Dog is equal to cat does not work. No, it does not. You would have to use a string compare function to do that. And we have this string chr, which finds the first or last occurrence of a character as well, which you might also be able to, use in some of the things that you do. Okay, let's see them in action. Yeah, let's see them in action. Let's see these strings in action. Okay, I'm going to try and use a few of them, okay? Okay, so what we have here is obviously I have included my string.h library so that I have these functions available to me. Otherwise, you will not be able to access them. I've still got this tiny little array that I've defined with a maximum length of 15. And then I'm going to start working my magic. So first I'm going to declare the array of characters, which is going to be a string, I hope. And I'm going to use this string copy, okay, to start with. So what string copy does is it works by using a destination and a source. So what I've said is I would like to copy into this array word, which I created on line 20, and then I give it a string to copy. So the string to copy is always in these double quotation marks because that's what says that it's a string. Otherwise, it's not going to work, okay? So then I can print out whatever the string is just so that you can see that it's working. Then an example of using length, okay, string length. If I use a string length on the string Sasha, then it will return to me the length of this string without including that null terminating character. So it should return 5. And then finally, we have this lovely string compare. And what string compare does is it compares two strings character by character. Now, it will return 0 if the strings are equal. And then there's, I can't remember, it returns either 1 or -1, depending which string has more things in common. And I can't remember which way is which, but you can read more about them. So if I do a comparison here, I've just said to you that it will return to me a 0, a 1, or a -1. And what that means is it's returning an int. So I'm going to store it inside an int variable. This compare string is a variable that I've made. So I've said string compare Sasha and Sasha, two strings that are not equal. So it should return something that is not 0 for me. And then I've compared two things that are equal just to show you what it will return. So let's try and run it. Okay, and it's called, keep doing a bracket instead of an underscore. All right, let's do the string demo. Fantastic. And let's run it. Okay, so the first thing that we were doing was that we were, here we go, I'll go this way. Okay, the first thing we were doing is we were copying this string Sasha into the empty array word up here. And then I was printing it out on line 25. So this is me printing out this line. So you can see that it's copied that string into that array because I'm printing out from the array. Then I've done the length. So I've counted the length of Sasha. And what do I get then? I should get 5 because there's 5 letters in my name. So again, it's not including that null terminating character. The first comparison of strings, the two are not the same. And it's returned a -1 because the two strings are not the same. In the second instance, I'm comparing what was inside this array, which we copied this string into, with the second string. And in this case, they are exactly the same. And that's returned 0 to me. Okay, so what that means is, again, you can see a whole bunch of functions that you can use that allow you to do a whole bunch of things that are quite handy. And you'll see the uses for them as we go as well. Okay, how are we going for time? 12:56. Oh, we're doing quite good time. Okay, actually, it might be a good time to take a break now because then I will introduce a bit of a new concept. Someone's asked, when will we get 1? You will get 1 if I swap these two around. So the 1 and the -1 are how many characters are in common based on where you're going. So you'll get 1 on either one or the other. I think if the first string has more characters in common, you'll get 1, and then the other way is -1. So usually you're comparing the strings based on whether they're the same or not, okay? So you really care deeply whether it's equal to 0. That's the one that you usually care deeply about. Okay, so let's have a quick 5-minute break before we go on to do an exciting thing called command line arguments, which will open a whole new exciting adventure for you as well. And then, you'll hopefully have time to consolidate these exciting new adventures in week 6 as well. So let's have a 5-minute break and we'll return back at 1:02. All right, we are back. I am loving all these wonderful ideas of how Jax and Juno can share this beautiful ring. It's just beautiful. If I think someone did pick it, this is a this question is not just a sort of a question of fun. It is actually fundamental in a particular key exchange, and it was a historic breakthrough, which was a historic breakthrough in cryptography. So basically, you have, Jax will send Juno a box with the ring in it and one of his padlocks on it. And when Juno receives this box, she will put her own padlock on it and mail it back with both padlocks on it. And when Jax receives that, he will remove his padlock and then send the box back to Juno. And then voila, it's all happening. So there we go. So exciting. It was, it's one of these simple riddles, but it was fundamental in this sort of, key exchange algorithm as well. Okay, fantastic. Let's go back to our wonderful, let's go back to our lecture, I guess. How exciting. I was just expecting something to echo or something to go wrong, but it didn't. So it was, it's all happening. Okay, we're on to command line arguments. I'm trying to think of which way I'm going to go. I'm going to go with this first, I think, with the lecture notes, because it's a good way to demonstrate it. Okay, so far in what we have done these amazing things so far. We've learned a lot. You guys can actually do so much already, and it's week 5 only, so that's pretty exciting. But you're about to learn how to do even more. So what happens is, so far you've used scanf to take input from the user, or you've used getchar, or we've just learned about fgets. So far we've had 3 ways to ask the user for some sort of input. And the way we can ask for that input is, once the program is already running, we ask the user for the input, and then we do something with that input, which forms part of our program. Now, there is a way to be able to give these types of inputs already on running the program. So when you first run the program, you give it some inputs to already work with, okay? So basically what this means, so far we've had this int main void, because the main function has never taken any arguments in. You just start running it, and then you take arguments within your code. And we're now going to see that change, because we're now going to see what it's like to take command line arguments. So if you have a look over here, anything you type on the command line, and that's what it's called a command line when you type in your bash terminal. What it is these are your arguments. So these are your actually input parameters. So in this case, you have an argument here, and it's the program name. You have an argument here that you've given it, an argument here, and an argument here. And you have already actually done this in DCC. You give the DCC quite a few arguments when you're running your DCC compiler, because you need to tell DCC what file to compile and what do you want the exit file, the source file, to be, okay? So you've actually been doing it already without even knowing. I mean, that's how clever you are. Okay, so let's have a look what actually happens in that case. So instead of writing int main void, which we've been doing all the time up until now, because we haven't been taking any input from the user at runtime, we've only been taking it when we're already running the program. What we're now doing is we're saying, actually, we're going to change this. It's going to be int argc char star argv array. Okay, you're going to be thrown by this beautiful thing here. Don't be thrown, don't be alarmed. This bit here never changes, kind of thing. So if you want to take command line arguments, this is going to be what you put in. It's like the formula for it, basically. So think about it like that in the sense. But basically, you will have int argc char star argv, and there is a meaning to them. So this first int argc, okay, that you specify as the input into your main function, that actually counts the number of command line arguments, okay? And that includes the name of your program, okay? So don't worry. I agree that char star looks pretty scary. Don't worry about this char star. What it's meaning is that you're creating this lovely array that you're going to store your strings in, okay? And char star is another way to say I'm going to be making a string for you, okay? You can see that it's a pointer of chars, but just think about it for now is that you're making this array of strings, okay? Because it's an array of characters, and we're going to play around with it so you can see how that works. So don't worry. And don't worry, this is just always going to be what you've made is you've made this array of strings and you're pointing to it. So each one of your command line arguments will be stored inside the argv array, okay? So for example, okay, there are currently 1, 2, 3, 4 things here. So argc would return 4 in this case because there's 4 arguments on this command line. And then your argv in index 0 of your argv is going to be the program name. So it's going to be this test6 over here. In argv1, because it's our array, is going to be this argument here. argv2 is this argument here, and argv3 is going to be this argument here. So it's quite a fun way. I know I keep calling everything fun. I really overuse the word fun, I think. Either that or you guys think that I probably do not know how to have fun because of the weirdest things that I call fun. But it's quite a neat way to be able to give something at the time of running the program. So what if you don't write a command line argument and run the program? That is a great question, Neil. If you have this int argc here, char star argv, okay, and you don't give any arguments to your program, nothing is going to happen unless you're trying to use one of those arguments. So if you're using an argument that is not there, so if your code involves doing something with the arguments that you've taken, in that case, it's going to yell at you, okay, because there's going to be nothing in that array. You haven't put anything into the array. You're going to be trying to access things that are not there. But if you're not using the argvs at any time, then it's not going to really do much. It's not going to yell at you or make you feel bad about it. Okay, so let's see it in action. Okay, so as you can see, what I've done is I have changed my void. Usually we're used to seeing void here, but you can see that I have done int argc char star argv array here. So what that means is I'm going to be taking input from the command line, okay? And then what I'm going to do is I'm going to say there are %d command line arguments in this program, and I'm going to use my variable argc over here to tell me what the count is of those command line arguments. So argc will count up how many things there are on the command line, which means that it will always include the name of the program as well, because it's just counting up how many things there are on the command line. Next, I'm going to print out the program name, and the program name is located in argv at index 0. So it's the very first thing on your command line. So I know that it's going to be inside argv 0. I'm going to print it as a string because argv array stores strings, and I'm going to also access that part of the array, so that argv at index 0. Okay, now I want to print out all the command line arguments that are given. If you notice here, I'm starting my index at 1. I'm not starting it at 0, okay? And the reason for that is because I've used index 0 up here already, and I've used it to say what the name of the program is. So now I'm starting it at 1 because I want to actually say what follows that program name. So what are the other command line arguments that are not my program name? So that means that the condition of my loop is going to be whilst I is less than, and it's going to be less than argc, because argc is the variable name for the counter that counts how many actually command line arguments there are. And then I'm going to print out the command line argument at index %d, located at argv%d, is actually the string. So what I'm saying here is that I want to have index I, argv%d, so that's another I, and my string is located in the array argv at index I, okay? And then I will increase my loop control, so I'll increment to the next one over. So let's see how it's actually going to work. So let's do DCC. Okay, so it's running nicely. Okay, so now this is my program. Oh, this is my program name over here. So this is what is stored inside argv0. Now let's see if I want to give it a few more things. Okay. Just taking things from the chat, and then I'm going to run it. Okay. So what's it going to give us? There are 7 command line arguments in this program. They are 1, 2, 3, 4, 5, 6, and 7. So if you notice, it takes them in separated by spaces. So each time it sees a space, it makes a new, it puts it into the next index. The program name is located at argv0 and is argv-demo. So this is what is located at the 0th index of my array, okay? And then what we get is command line at argument at index 1 is Alvin, at index 2 is Loves, at index 3 is his, index 4 is 6. I'd like for you to notice that it's still printing out this number 6, even though really we've got strings, don't we? So remember that in C, all of it has to do with the ASCII table. So even though I've got this number 6, it's on the ASCII table, it's read it in as a certain number, but I would not be able to do any mathematical operations on this 6, okay? Because right now it is kind of like a string, it's kind of like a char. So it's not a number per se that I can do maths on. And then so on and so forth. So what it allows us to do is it allows us to give arguments on our command line, and we can even do things, we can change stuff that we've written already by, just doing these command line arguments. Can you accept integers or doubles in command line? You can accept integers for sure. Great question, because I'm heading towards it. I am heading towards how you can actually strip it down and convert it to an integer that you can actually do maths calculations with. So we're heading towards there, but great question. Okay, so that is your command line arguments, and what they allow you to do is take things in from the command line, which allows you to have more flexibility in how you write your code, which is always quite nice. We like to have flexibility. And so now let's go on to this lovely question that is asking, well, what do we do if we actually want to have a number, one that I can do some maths with? Well, what we can do then is we can use this wonderful function that is available to us that's called a to I. And this function converts an ASCII to an integer. And it is located in the standard library stdlib.h, okay? So if I want to use the function a to I, what I'm going to do is I'm going to hash include standard library.h. So I'm going to include this stdlib.h. So once I include that, notice again my int main is not void. It is int argc char star argv, which is what's going to say to me that I'm going to take things in from the command line. And what I want to do now is I want to take numbers from the command line, and when my program runs, I want to give the sum of those numbers. Okay, so let's see how we would do that. So let's say we've got an int sum. I've initialized it to 0. I've started my index at 1 because if you remember, 0 is the program name. So I don't really want to take in the program name to do anything with it because it's not giving me really anything useful right now. So I want to start at index 1, which is going to actually give me, something of value, the numbers that I want. Okay, my condition is going to be whilst I is less than, and then I need to use that counter that counts how many command line arguments I have, okay? And in this case, it's argc, which counts how many command line arguments I have. And then I will have the command line argument. I'm going to list out the command line arguments as well, just so that we get extra practice to see what's going on. And then I will go back to demonstrate what Alvin is saying in this 2D array. I'll show you what Alvin means as well by that. Okay, so the command line argument at index %d, argv%d is %d, okay? So what I want to do, if you notice, I'm no longer printing out a string. I want to print out an integer, okay? And the way to do that is I'm going to have, index I, and now I'm going to use my function that will convert whatever that number is as a char. It will convert it to an actual integer that I can do some maths with. So before I do any maths, I need to convert whatever is sitting inside argvi. I'm going to convert it to an integer. So I've used this function a to I. The function is inside this library stdlib.h. So I've used this function, and when I use this function, I give it what I want to change from an ASCII to an integer. And what I want to change from ASCII to integer is I want to change what is sitting inside my argv at index I. And that means that I now get to add to it, a lovely, again, I want to add a number. So that means I need to use this a to I again. And again, I'm giving it whatever is sitting inside that argv at index I. So let's see it in action. I'll save it, go to terminal. Okay, so let's do, that would not work because I've got the wrong name. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's see what it tells us. It is telling us what is sitting inside all of our different arguments. And then what it's able to do is, because we've used that a to I, it's been able to add all of these up to give me an actual sum, okay? So that is a pretty exciting thing to have done, because now you're able to take things from the command line and convert them straight away to do mathematical operations on them as well. And I hope that answers your question, Neil, as well. Okay, so there's been a lot of stuff in the chat about this array of array of array of array. So I'm just going to quickly go back to argv demo and show you what Alvin means as well. And he's explained it pretty well in there. So it's basically a 2-dimensional array of characters or a 1-dimensional array of string, which means what I can do is, I'm just going to be a bit, I'm going to put in one word and then I'm going to show you what I'm going to do. So you can print out a character by accessing which array you want. So let's say I've got my, let's say I'm putting in, okay, I'll just put in Alvin's name. Why not? Okay, Alvin. It doesn't want to put your name. It keeps auto-correcting me to end. Okay, here we go. Okay, if I put in Alvin's name, what this means is that inside argv, and let's say I've got my program. So my program is /argv demo, and then I've got Alvin. So what it means that inside my index 0, I'm going to have the program name. And then what it means that inside argv1, I'm going to have the string Alvin. Yep. Okay, now what that means is that I can access this string a character at a time by using this concept of the whole 2-day. So if I'm accessing the first index and I'm going to access the 0th element, what that will give me is the character A. If I access inside this first string and I access the first index, it's going to give me the next thing, which is L, and so on and so forth. So it makes it possible to really break it down even further. And just to demonstrate for you, let me do a quick, I'll just do a quick printf just to demonstrate it quickly before we go on. Okay, here we go. Okay, and now I'm going to run it. Anyway, it doesn't matter what it's got on there. So as you can see, my argv at 10 is A, because what we get is argv1 is equal to Alvin, and its 0th index of the array string Alvin is the A. Okay, so you get this lovely situation where you can break it down even further. So it's an array within an array. Yeah. Again, it allows you to do a whole bunch of things. Okay, so it allows you to really do a whole bunch of breaking down these strings even further if you need to. There's a lot of questions. Let's have a look. Anything, Alvin, is there anything that I need to answer on the lecture? Somewhat. Oh, A to I, yeah, a toy. I'm like, what is, sorry, I was like, what's a toy? Yeah, okay. So people have not enjoyed the A to I. So A to I is a function that is available to you that converts an ASCII character to an integer. So what that means is when on my command line, okay, when I enter things on the command line and I'll enter an 8 or a 9 or a 10. So I'm entering a number, okay, but remember that when it goes inside my argv, it's storing it as chars. And then if you remember from our playing around with chars, that's actually ASCII numbers, okay? So in this case, what happens is this is not really a number that I can do maths with because it's stored as a char. So what A to I does is A to I allows us to convert this ASCII character for 8. It allows us to convert it into the actual number 8. So into the integer 8. And if you remember, you know, we had played around with doing it in code, but you can just borrow this function A to I, and it will allow you to do that, you know, just by calling this function ASCII to integer. So it will convert an ASCII value to an actual integer as long as it's obviously a number. Okay, so hopefully that explained it. Okay, Becky's asked an excellent question as well. What if I did argv30? Okay, great question. Let's have a look. And this is the best way to find out what it does. And what was on argv3? I think argv3 1, 2, 3. So it was the word his. But I think Becky wanted it for the number, maybe. I'm not sure. Okay, here we go. Okay, so if I do it for the word 3, it's really going to do the same thing for me, but it's going to use the third term. And the third term, argv at index 3, is actually his. So the first element in this word his is going to be the H, which means that I'm going to get the H over here as my index at 30. Now, what happens if I try and access something? And this is another question that was asked. What happens if I do this? Okay, I don't give it any command line arguments, but what I've done is I have asked for command line arguments in my code. Okay, so what's happened is it said there's one command line argument in this program. The program name is located in argv0 and it's argv demo. And it's given me some absolute rubbish here, which doesn't really exist, which is quite interesting. And what happens usually when we require command line arguments, okay, when we actually ask the user to input command line arguments, we will have a certain number of command line arguments that we would like them to put in, and we safeguard for them to put it. So if you remember when we did scanf, we checked that they were scanning in the right amount of things. We kind of do the same thing when we do command line arguments, in that we insist that they put in at least a few. So I would ask for them to have my argc to be greater than or equal to something else. So let's see it in action. I'm not just going to explain it and leave it. Let's see it in action. So let's go to a bigger coding problem that we will try and do. And then we will try and solve a bigger coding problem. Okay, I went a little bit crazy here on this question because I really wanted to demonstrate a few different things. So again, what I want to reiterate is that there is always more than one way to solve a problem with code. And usually you have more efficient ways or less efficient ways. We don't really care so much about efficiency in 1511. So in our case, what we really want to do is sometimes I will solve a problem. It's not going to be a particularly efficient solution because I want to demonstrate a few different things in solving that problem. So I'll use more functions that I need to, or I'll kind of break things down further than I need to because I'm trying to demonstrate something. So whilst it provides a good idea, just keep that in mind. There's always more than one solution. There is a little bit of gray area in computing. So, just keep an open mind. Okay, so let's have a look. So your task is to read in 2 strings from the command line. Okay, I'm going to start using some of those string functions as well, just to make it even more fun. Again, overuse of the word fun. The first of these arguments will be either the word numbers or words, and this will allow you to know what needs to be compared. Obviously you'll never get a problem like this. This problem has, a few moving parts and it doesn't particularly make huge amounts of contextual sense, but I'm trying to demonstrate 2 different things, so we're going to go with it. This will allow you to know what needs to be compared, and the next command line argument will either be a number or a word, depending on what you are comparing. Another string will then be prompted from the user once the program starts, and the 2 strings will be compared for similarity. If the string is a word, then the number of similar letters will be counted. Otherwise, if the string is a number, we will say whether the 2 numbers match. So a lot of moving parts. For now, I would like to do the moving part that has us moving the first few bits. Okay, so let's focus on the words to start with. And I've provided you some starter code as well so that we're not doing this from scratch. Again, implementing things that we already know how to implement as well. Okay, so in our starter code, what do we have? We have including a whole bunch of libraries. We've included our normal one, stdio.h, without which we can't run scanf and printf. I've included string.h because we're obviously going to be comparing some strings. And in that case, I need to access the functions that are available in the standard library string.h. And I've also included this stdlib.h, the standard library, because if I'm comparing numbers, I probably want to be able to access the a to I function, and that's located in this standard library function. Okay, I've got a hash defined for a maximum length of an array, and it's set at 100. I would also clearly like to see 2 functions being made. One that will match words, one that will match characters. So we'll count up the characters that are similar. So don't worry so much about what's included in that. As we go to this function, I will explain what they mean and why it's got pointers. I'm obviously also using pointers so that you guys get a little bit of practice using pointers as well. Okay, because we're taking things in from the command line, I am again not using void inside the brackets, but I'm using int argc char star argv, which straight away allows me to take things from the command line. Okay, so this is where we were talking about checking things. The way we checked whether scanf has gotten in the right amount of things, whether it's scanning in the right amount of characters or numbers. We can do the same things by checking our command line argument. So I have said in the question that we want to take in 2 command line arguments in addition to the name of the program, okay? And those 2 command line arguments are going to be a keyword, either numbers or words, and then it's going to be the word or the number that I want to compare. So that means my argc should be, I'm going to check if there are 2 arguments, and if there are less, then I'm going to exit the program. So if argc, which is what counts up the number of arguments, not the amount, the number of arguments in my command line, if it's less than or equal to 2, then I'm going to say you need to enter whether you want to compare, and that doesn't make sense, that error. I obviously combined a few pieces of code and that absolutely does not make any sense. So let's change this error message to be something that does make sense. Okay. Okay, so I'll just say you have not entered enough command line arguments. Please enter a word or a number to compare. Okay, and then you can see I'm returning 1. I know some people are still confused by the returns of 0s or 1s. When I return 1, it usually means, when I'm returning, it means come out of this function, okay, I'm finished. And usually as a standard input, when I return 1 in this particular context, okay, this doesn't always apply, it means I've exited out with an error, okay, so I haven't finished running smoothly. So if there is, and someone has said, wouldn't not equal to 2 make more sense? It would absolutely make more sense. Well done on picking up this logic issue before I had time to run it with different inputs. That's very good. It would absolutely make more sense because I am awaiting exactly 2 inputs. Okay, so in this case, it would say if it's not equal, which means what it will encompass is if there's less inputs than 2 or if there's more inputs than 2. I really don't want there to be any more, any less. I want there to be exactly 2 inputs. But do I want there to be 2 inputs or do I want there to be other? We'll have a look in a second. Okay, now I want to be able to check the keyword, okay? So one thing to know that the final element of argv, so the final index of argv is going to be argc minus 1. And the reason it's minus 1 is because inside argv0, we're going to have the program name. So again, it's indexing from 0, which means that, and the amount argc counts that 0th index in its numbers. So that means that it's going to be subtracting 1. So if the first command line argument is a word, then compare the 2 words for matches. So I want to know if that first command line argument is the keyword words, okay? So I want to be able to compare 2 functions, right? So let's do that. Let's compare 2 functions. Now, who remembers what was the function that allowed us to compare 2 strings? I think I just said functions. Sorry, I meant strings. Who remembers what is the function that allows us to compare 2 strings? Yeah, well done. So string compare, strcmp. Okay, so if I'm using my string compare function, I'm going to have here, so if my string compare And what am I comparing? I'm comparing what is sitting inside my argument. So inside my argv at index 1, because at index 0 is just my program name. So then I'm going to compare this argv1, and I'm going to compare it to the string, to the keyword words. And if it says, if these two, so if they're the same, then I want to be able to do something. Who remembers how do I denote the fact that they're the same? Who remembers what string compare equals to when they are the same? And Keanu, yes, you're absolutely right, which is why I said, oh, is it going to be 2? Let's wait a little bit. So yeah, you're right. argc is actually going to be 3 in our case, because we're going to have the program name. So we're going to have, this is going to be the first command line argument. Then we're going to have a keyword, and then we're going to have another one. So absolutely. And well done. It will return 0. Okay. So if this string compare is equal to 0, in that case, I want to compare 2 words. Okay, so if it's equal to 0, then I'm going to take in another string to compare it to. So what I will do is I'm going to do, please type in a word to compare. I then have declared an array of characters. And then I want to be able to take that lovely word in, okay? How can we take a whole string in? Who remembers the function that we can use to take a whole string in? Who remembers? At the beginning of this lecture today, we did a function before I started. No, it was after. Well done, fgets. Well done. Okay, so let's fgets this line. So we're going to fgets. Remember, fgets requires 3 things in it, okay? First of all, it requires the array into which we are storing, that's input line. I'm really sorry, I'm starting to lose my voice because of this cold, so it's going to be a bit crackly for the next 15 minutes. So the first thing is going to be our array, the word to compare, where I want to store things into. The second thing is going to be my length, so the maximum length that that array can take. And the third thing is where the input is coming from. And in our case, it's coming from the terminal. So stdin, standard input. Okay, so we're going to take in this line. And now if you remember seeing what fgets did, is that it scans in an enter as well, because an enter is a char. So when I do a new line, in fact, it still has a char. And yesterday, someone asked, what do we do when we have this, new line? How do we get rid of it? So I thought, oh, okay, well, this is a great time to show you how to get rid of this new line. And all I need to do is I really need to, basically decide what happened at the end. And if the last letter of my string is going to be, if the last letter of my string is a new line, then I want to get rid of it. So let's see how we're going to do it. This is going to be very exciting. I didn't use the word fun, exciting this time. Okay, so let's check for new line and remove it if it is there. Okay, so how do we determine, because what we saw when we did fgets is that the maximum length is not necessarily the length that goes inside this array. So we might actually have less things inside this array. Who remembers the function that we can use to get the length of the array? Well done. People remember, yay. We can use this function called string length, okay? And the output of it is going to be an int that's going to give me the length of my string. And remember, it does not include that lovely end bit. So I'm going to measure my string. So I'm going to use this string length, and I'm going to have what's going to be my word to compare is the one that I want to compare. And then what I want to do is I want to subtract 1 from it, okay? Because then it will give me that lovely, it will actually give me the last array of my, the last index of my array. So my last letter is going to be inside the index, string length, whatever that array, the length of it is, minus 1, okay? And now I want to see if it is equal to a new line. So if this last letter, if whatever is sitting inside my array at last letter, not my last letter. So if whatever is sitting inside my array, so word to compare at the index last letter. So if this character is equal to a new line character, okay, then what I want to do is I want to kill that new line. Again, very aggressive, I'm sorry. And instead of that new line, what I want to do is I want to say, actually, I want to finish that string. So what I can do, if it's equal to that, then at that last index, instead of having that new line, I can assign a null terminating character, which means that my string has finished, okay? So what it means is that I have cut this new line, and instead of this new line, I've told it move this null terminating character into the last index. Okay, so we've done it, we've removed it. Have I gone the opposite way? Okay, so what have we got now? Now we've got a piece of code that is able to take in a line. It's able to trim it down, get rid of the new line, okay? And now we can do some matching, I think, at this stage. So let's do that. Okay, so this is where the action starts, where we're actually going to do some comparison. Okay, so as you can see here, I am going to match the number of letters. I'm going to say how many things match, okay? And I'm going to call a function called word match, and I'm going to give it the word to compare, which is the word that was the string that came in from the terminal. And I'm also going to give it my last argument. So the argument that actually has the string that I want comparison to. And then I'm going to output how many letters matched. So let's go and have a look at this word match function and what we can do with it. So we're going to try and see how many characters inside these two words are matching up. Okay. Okay. So what we want to do in here, let me press a few spaces here. Okay, so what we want to be doing is we want to be going through the first word, okay, and we want to be seeing if something is matching inside there. So how many characters are matching in here? So if we were to draw it up, I'm a big fan of drawing things up. Let me go in here. Oh, sorry, you get to see my kids. Apologies. Okay. So what we get to see here is how it's going to work. So let's have a look. Why am I not drawing on here? My pen has run out of battery. I'm done with technology. It's all going out the window. Okay, in this case, I'm not going to do that. I'm going to share something else with you. I'm going to have to draw it just in here. Okay, so let's say on the command line, the first word that is coming in is technology, and I want to compare it to the word sucks. Okay, I want to go through and compare. So I want to see if the letters inside the first word are going to match the letters inside the second word. But what I'm going to do is I'm going to take a letter inside here. So let's say I'm going to take T, okay, and I'm going to compare it, run through the word sucks, and I'm going to see if T is located in here, okay? And if it's not, then I'm not going to count it. Then what I want to do is I want to take the letter E and run through the word sucks and see if it appears in the word sucks, okay? Then I'm going to take the word C and so on and so forth until I find, a match, and then I'm going to count it up. All right, so what does that mean that we have there? Okay, let's keep track of how many matches we have. So I'm going to have a variable to keep track of the matches, and I'm going to have an index because I'm going to need to comb through the array. So I'm going to set my index at 0, and that will allow me to comb through my array to reach a particular thing. I'm not a boomer. I think no, I don't actually know what I am. Maybe Gen Z? No. Millennial? No, I'm not millennial. Who knows? I'm old, but not that old. Okay, so let's go through. So what I want to do is I want to take the character, okay? So as long as my character is not equal to a null terminating character, which means I've come to the end of the string. So I want to take a character until I've reached the end here, because at the end, I actually have a null terminating character as well. So until I've reached this end of the line for my string, I'm going to keep going, okay? So in my case, I'll take a character from inside the word that I passed into this function. And what that means, and Ali, I do know that it does, but my iPad is currently plugged into my computer, which is why I can't plug in the pencil into my iPad. And the cord that is plugged into my computer has the dongle on it that is plugged into the iPad. So I can't even plug it into the dongle, okay? So it's like a comedy of errors and technological issues at the current time. And I only have one cord plugged into my computer right now. So that's why I have not been able to plug it in. And I should note that I charged it this morning. I don't know why it keeps discharging so quickly. Okay, so I've got my while loop. So now I want to check if that letter is actually located inside, okay? My iPad is not that new, so it cannot do that. Mine cannot charge. Plug it into your phone. I didn't even realize I could do that. Amazing. Okay, so I've learned something today as well. Amazing. Okay, so let's have a look. So we're going through and we want to check now what's going on, okay? So we want to check if that character is located inside the word. And so what I've done is I've actually done a new function as well, because why not? Functions are super fun. So we want to be able to see another use of function. Okay, and if my char match, so I'm going to call this, char match. So I'm going to send it this letter, and I'm going to send it my second word as well. So if this is equal to, if this is greater than or equal to 0, so if I've had a match, which I'm going to return back to it, then what I will do is make typing mistakes. No, I won't, okay? Then I want to increase this matches, which is going to keep count of how many characters are the same. Okay, and then, of course, I shouldn't forget to increment my I++. And what do I want to return back? I am returning an int from this function, and I would imagine that I want to return how many things have actually matched up. So I'm going to return this variable matches, which is keeping track of how many things there are that have matched, how many characters have matched up. So now let's see if we can scroll through and we can match things up on our actual character match. Okay, let's do, I might print out what I'm matching against what, okay? Because that will allow you to see what's actually going on inside the code. So again, this is used like a debugging statement because it's going to actually tell us what our program is doing. So it's telling us what has gone into the function. So we will be able to see if something is working or not. So I'm checking the character against in Word, and I'm going to check it in the string Word. Okay, and then I'm going to do a new line. And the character that I'm checking is this character that I've just sent over here. So I'm going to check this character and I'm going to check it against my second word. So that's just really going to be able to tell us what's going on inside, okay? So now let's see how we can actually go through and move around. So whilst, again, we're going to keep going until the second word hasn't reached that null terminating character. So we want to check every single thing in the second word against that letter that's come in. So while it has not reached the null terminating character, we're going to increase the index and keep moving. So whilst my word 2 at index I is not equal to that null terminating character, we're going to check. So if it's equal, so if my index on word 2, so if inside this, when I'm checking through the indexes of this string here, if something matches to the character that I've centered, so if it's equal to this character, then I want to actually count it as a match. Yeah. Okay, so I need to also keep track of what I'm doing here. So I'm going to say found letter, and I'm going to make it equal to -1 in this case because you can still have a 0, but I can't have a -1 as a found. And if they match, then what I'm going to do is I'm going to make it equal to, I don't know, let's do the index at which it was found. Why not? Because all I'm going to do here is I'm going to return an index. And when I return the index, okay, and this is a weird way to do it, I'm sorry, I'm just trying to use functions, but when I return the index to this word match, all it does, it doesn't really care what I return to it, as long as it's 0, greater than or equal to 0, which is the indexes of my array, it's just going to add 1 to my matches. So this is not telling me how many letters have matched, but it's telling me the index at which I matched. And what it means is that I'm able to count every index that has matched up. So then I'm going to return, and I'm going to return this index to it. And if the index is greater than or equal to 0, which means that it has been found, then what that means is it's going to count it as a match. All right, I've written a lot of code. I think it's probably time to see if anything runs as well. And we're nearing the end, so I want to see what runs so we can fix a few things as well. Woo! And this is why you shouldn't write so much code before running DCC, because you're just going to have a nightmare of a time fixing things now. All right, so if we go to debug, let's have a look. Oh, it's because I have a whole bunch of erroneous things there that I've left open for us to be able to do other programming. So what I'm going to do is I'm going to get rid of this else if. I'm just going to put it inside commented out because it's causing quite a few issues for me. And then we're going to try running it again. And still there are some problems. So let's have a look. I might have forgotten to do things here. Undeclared identifier. So I'm using somewhere an index that's not declared. Where am I using it? I'm using it right here. So let's save it again, run it again. Okay, still some errors. Let's have a look. What is wrong now? Use of undeclared identifier. Okay, I've used somewhere something called word when it should be. Yes, very good. Should be word 1, and it should be word 1. This is almost telling me I've got bad variable names. I'll clear the screen so that you can see, okay? So now I've got issues on line 95 with my brackets, I believe, yes. I think I should have a bracket here as well. Yes, okay, so that's fixing a bracket. And let's try running it again. And it compiles. How exciting, okay? So now if I run it, I want to compare words because there's no numbers to compare yet. And the first word I'm going to do is technology. So you can see that it's gone straight through to the if statement, which means my first comparison has worked. And it's asked, please type in a word to compare. I put in sucks. The number of letters that matches is 1. Is that right? I don't think that's right. No, there's clearly a logic mistake because it should be 0. Oh, no, it should be 1. There is a C there and a C here. Okay, so that is working. I could have hoped for a logical mistake. Okay, so as you can see that it checked one word against the other word and then it matched up the different letters. And the reason, I didn't have to have 2 functions. I could have done it all in 1 function. That doesn't really matter. You saw me passing around a lot of pointers as well, which is, I think people did not love the pointers. And the reason I'm passing the pointers around is because I'm dealing straight away with the memory addresses at the source. So I'm not really needing to do much. And usually when you want to pass an array, you actually pass a pointer to the array. So if you see this kind of char star and it's something, you can treat it as an array, okay? But you usually pass it as a pointer, but you're really passing an array. So what this really means here is it's saying I want to pass to it a char word array and another char word array. So treat it as an array and it will make you feel so much better. It will make your life so much easier. Just like inside our main, when we have this char star argv array, we're treating it as an array of arguments, okay? It's an array of strings. All right, we're going to finish there for today. I think we did we had almost no issues. That was a little bit exciting. I hope that you all have a wonderful flexibility week. I hope that you actually get a chance to have at least one day off. Good luck catching up on everything. Good luck relaxing a little bit and hopefully seeing some friends as well. Please do take the time to actually chill as well as catch up on your work. It's really important to take breaks. All our help sessions are still running. So if you need help with anything, please come to our help sessions. They are open and running. So enjoy your next week, and I look forward to seeing you in 1 week's time in week 7 for more excitement. We're going to learn about a whole new data structure, which is going to be super exciting as well. Super fun. Oh, don't worry about calling me a boomer. Just don't call me ma'am. Anytime anyone calls me ma'am, hard no. Hard no. All right, see you guys. Bye.